Figure 8.13, attempting to modify a constant pointer to non-constant data. Here we have a mechanical example that is designed specifically to produce a compilation error. And in the example, we want to demonstrate placing the const keyword on the right side of an asterisk that declares a pointer. So here in main, we have two integer variables, x and y, that we've declared. And here is the key declaration for this example. We have the variable ptr, which is a constant pointer to an integer. Remember, when you're reading your pointer declarations, you read them from right to left. So again, ptr is a constant pointer to an integer. A constant pointer is a pointer that, number one, must be initialized when it's declared, and number two, cannot be aimed at a different variable in memory once it's been initialized. The data that it's pointing to in this case is an integer variable, and that integer is not considered to be constant. So if you take a look here, we have the expression star ptr, which would dereference this pointer and assign the value 7 to whatever ptr points to, which is the variable x in memory. On the other hand, we also have this pointer at line 14, or this expression rather at line 14, where we attempt to say to ptr, assign it the address of a different variable. So ptr was initialized to point to x. Now we're trying to make it point to y, but because ptr is a constant pointer, we cannot modify its location. And in fact, the name of an array is actually a constant pointer to the first element of the array. The name of an array always points to the first element of that array. So the concept that you're seeing here is basically how array names are declared by default in C++. And if I hover over this ptr, by the way, you can see that the expression must be a modifiable L value, which basically means that ptr is not modifiable, and that again is because it was declared as a constant pointer.